Hey guys, I wanted to talk to y'all today about making a box plot and kind of what a box plot can tell us compared to other graphs, what quartiles mean, and then we're also going to talk about how to calculate outliers. I told you guys we were going to do that, so we'll learn the formula today for calculating outliers. The big deal with box plots is they take and they are 5 points. There are these 5 points down here, which we call the five-number summary. And what they do is they break your data into quarters, which is what I put up here. The quartiles, which are Q1 and Q3, they kind of break your data. Well, they're part of the five-number summary, so they do break your data into quarters. And then you could kind of call the median Q2. And the idea is that 25% of the data is to the left of Q1, or let's say approximately, because depending on the number of data points you have, you may not be able to break it into quarters very easily. And then Q3 is going to be, you'll have 75%, approximately 75% of the data to the left. And then, the median, which you guys already know about, is 50% of the data lies to the left and 50% to the right. And so this is important to us sometimes to be able to look and see, do I have a bunch of data, that early in my data set? Do I have a bunch of data late in my data set? And just kind of, it gives you an idea of how the data is spread out. Um, Figuring out your quartiles is pretty basic. Let me show you how to calculate them, and then we'll come back to IQR. So basically, you're going to find the median, which is what they've done here. These are 15 worker travel times in North Carolina. So there is an odd number of data points. So we're just going to take, and that means that our middle value is going to be the median. And so basically, Q1 is just the median of the first half. So the median of the first half of the data set. And then Q3, here we go, is going to be the median of the second half of the data set. And so you would just order them all, even if you have an even number of data points and you have to take those two in the center and average them, then you would include those when you're finding your Q1 and Q3. In this case, since the median is an actual data point, we're not going to include it whenever we're trying to, count out Q1 and Q3. Another measure of spread that we can use, like saying when we're cussing and describing distributions, is what's called the interquartile range, and it's basically the middle 50% of your data. So what happens is you all know, I just told you that Q1 is 25% to the left, Q3 is 75% to the left, which means between those two is the middle 50% of your data. And if these two numbers are really far apart, then you've got a fairly large spread. If they're close together, you have a small spread, at least in the middle of the data. And so basically you're just going to calculate each one and then subtract Q3 minus Q1. If I look at this example right here down below, then my IQR would be 30 minus 10. Oh, if I could write, that'd be helpful, which is 20. So once again, just like whenever we talked about range, IQR is just one number. Any kind of range is always going to be one number. So don't tell me the IQR is 10 to 30. Subtract them and get me that single number. Okay, now you guys know what IQR is. I can explain to you how to calculate outliers. So here's the formula. So the idea is that if you take your Q3 and you add 1.5 times your IQR, then any number above this value, so let's say any number greater than, and this is strict, right? So if you have a number that's equal to that, then it's not going to be an outlier. Any number greater than Q3 plus 1.5 times your IQR is going to be an outlier. Any number that's smaller than, and this is once again a strict inequality, meaning that we wouldn't include it, that's smaller than Q1 minus 1.5 times your IQR. So 1.5 times the middle 50% above or below the quartiles are going to be outliers. So let's take a look at a data set. Let's take a look at this data set up here that we just did. And we already know Q1 and Q3. And I haven't seen a graph of this data yet, but let's check and see if we have any outliers. 60 is a little above everything else. I'm not quite sure if it's going to be above enough to make it an outlier. So if we go down here, we know that for the 15 times, our IQR was 20, right? And our Q1 was 10, and our Q3 was, what, 30? Yeah, 30. So if we take Q3 and we add 1.5 times our IQR, this is going to be 30 plus 1.5 times 20, which is going to be 30 plus 30, which is 60. Now, we have a data point that's equal to 60, but we don't have any that are greater than 60. So no data greater than 60. So we have no, and I usually call these, although I don't think it's a very proper term, no upper or high outliers. Because you can have them on either side. All right, so let's check the other way. So we have Q3. No, sorry, my bad. Q1 minus 1.5 times your IQR, right? So Q1 is 10 minus 1.5 times 20. And then this one's going to be a little obvious because it's going to be negative 20. And I would love to be able to get to work in negative 20 minutes, but I don't think that's really feasible. So we have no lower outliers. You could definitely have more than one outlier in your data set. You could have outliers on either side. If you are cussing and say you're given like a histogram, I wouldn't expect you guys to actually go through and calculate outliers. I would expect you guys to kind of do it the same way we've always been doing it. Now, if you were making a box plot and they specifically told you to check for outliers, then you would have to use this formula and actually check for outliers. So don't, I wouldn't say waste your time, but don't, if you're cussing and so forth, don't spend a lot of time actually trying to use this formula to calculate them. Because generally when we're looking at a graph and we're describing it, it's all just kind of approximate. All right, so last thing we have to do is we have to learn how to make a box plot. So we're going to take this data. Let's see what's on the next page. Okay, y'all are going to do this one on your own, but let's take this data up here that we just used, and I'll show you guys how to make a box plot. Basically, all it is it's a graph of the 5-number summary. At minimum, Q1, and so forth. And I'm going to show you guys how to do it on your calculator also, whenever we look at this next example. A modified box plot is going to be where the outliers are denoted with asterisks or little boxes or marks or something extra. And your calculator will make both a regular box plot and a modified box plot for you. I like modified box plots better because they just give you a little more information. But I don't know, either way, I guess. So let's go back to this data that we just had. And let's see how, if we can make a box plot from this data. I think actually what I'll do is I'll take this thing and I will copy it. And I'll just put it on a new page. There we go. All right, so let's write down for this data our 5-number summary. So our minimum is just the smallest data point, which is 5. Our max, our Q1, I'll do them in order, is going to be 10, right? Our median, I'm having a hard time writing today, is going to be what? 20. Our Q3 is going to be 30. And then our maximum is going to be 60. All right, so in a box plot, you basically, since you only have those 5 numbers you want to graph, you basically only use an x-axis. And you could care less about the actual height of your bars, or of your box. The height of the box or the width or whatever you might call it really has no meaning. You can make a skinny one or you can make a fat one. Please make sure that you don't just label the 5-number summary on your axis, but you actually make a good scale. Like I'll start at 0, and then I'll go, let's see, 10, 20, 30, 40, 50, 60, and then I might mark the 5s in the middle, and then that's 20. So, and you guys, I've complained to y'all about this before, like when y'all were making dot plots and stuff. Always make sure that your axis is a real number line. Don't just mark what you want to. Every axis is going to be a number line when you're graphing quantitative data. Okay, so here's how you do a box plot. You're going to make a rectangle that goes from Q1 to Q3. So my Q1 is 10. My Q3 is 30, right? And then I'm just going to make a rectangle. Once again, this height right here doesn't matter at all. It can be skinny, it can be fat. So here's my Q1, and there's my Q3, and then I mark the median in the middle. That's going to be 20. And then my minimum is going to be 5, and my maximum is going to be 60. So I draw one little line, and then I kind of put a mark that indicates that's the minimum, and then I draw another line from Q3 to the maximum, and then put a little mark where that was the maximum. Say if, it's not true because we already did it, but if 60 was an outlier, then this is how our modified box plot would look. We would put our mark for our maximum at the last data point before the outlier, and then we would just put a little star there at 60, and that would make it a modified box plot. So you guys, since you already know how to do this, I'll kind of just give an explanation. I think this is the most you'd want to do with a calculator at this point, but if you run your 1-bar stats, and we did this last class, so what you'd want to do is, you'd put your data in L1, and then you would go stat calc number 1 1-bar stats. Then this will actually calculate your 5-number summary for you, which makes it a little less tedious. I mean, I know we all don't want to like order the data and find the median by hand and then find Q1 and Q3 by hand. So let's just not do that. I mean, I'm not about all the tediousness. So then you'd have to actually scroll down once you run your 1-bar stats, and then you'll see your 5-number summary. And then that'll make it a lot easier for you to make a box plot. All right, so what I want you guys to do, since this is in your notes, is to pause the video, work this example, make a box plot, and then replay it, and we'll take a look at your answer. How does that sound? Okay, I'll see y'all back in a second. Okay, so let's see what you guys came up with, and then we can compare ours. I think that mine is correct. You could have checked for outliers if you wanted to. I didn't tell you to. It actually, although 73 seems like an outlier, it really wasn't. It was pretty close. When you check for outliers, they had to be greater, the maximum had to be greater than like 74.25, and then the minimum had to be less than negative 3.75, which doesn't make a lot of sense. So you didn't end up with any outliers. um, I would have, since I kind of explained to you how to do it, taken all this data, stuck it in L1, and then ran my one bar stats to get my 5 number summary. I hope that's what y'all did. I mean, you could have done it by hand if you wanted to, but just taking a data set and putting it in order is annoying enough. But so when I ran my 5 number summary, I got 16, 25.5, 30, 4, 45, and 73. And so I just marked all those, on my axis. Notice that I didn't put a lot of detail into my axis, but it allows you to get the gist. And then one thing I screwed up on before, because I'm good at that, is I forgot to label my axis. So please label your axes um, so that I know what the graph means. So I guess that's all. That's pretty nice short video. I hope you guys learned how to make some box plots and you learned how to calculate outliers, and I'll see y'all later.